All right, so the first law of thermodynamics is a statement of the principle of conservation of energy. So what's energy? Well, energy is something that's inherent in all matter, and the total amount of energy in the body cannot be measured. So we measure energy above some arbitrary datum. For example, take the potential energy of a pound of water. Well, we would take that to be the change in potential energy that the pound of water would undergo in falling from, say, a reservoir to a power plant. The level of the power plant will be the datum level, right? So, in like manner, other forms of energy are measured above this so-called datum state. Energy is a scalar quantity, not a vector quantity. And the energy of a system of bodies is simply the sum of the energies of the individual bodies. And the total energy of a single body or substance is the sum of the magnitudes of the various forms of energy that the body or substance possesses. So you have three forms of energy. You have mechanical potential energy, which is also called gravitational potential energy, and it's the energy a body possesses due to its position or elevation, and it arises due to the attractive forces between bodies. You also have mechanical kinetic energy, which is the energy that a body possesses due to its speed. Speed with respect to like a reference point, all right? And you also have internal energy, which is energy that is stored in a substance, right? And this energy is due to the activity and configuration of its molecules and the vibration of the atoms within the molecules. So internal energy itself is also composed of internal potential energy and internal kinetic energy, right? So the total internal kinetic energy arises from the translational motion of the molecules, the rotational motion of the molecules, and the vibratory motion of the atoms within the molecules. Internal potential energy arises from the relative position of the molecules, like with respect to each other, right? Now, say like in this video I have here, I was going to evaporate this amount of water that I have completely and collect all of the steam. Now, the same amount of steam will occupy a much higher volume than the same amount of liquid water. So the molecules in the steam are much more spread out than the molecules of the normal water. To move these molecules apart against their attractive force requires a large amount of energy, which is stored in the steam as part of the steam's internal energy. When and if the steam is condensed, the same amount of internal potential energy will be given up.